Ever pondered over the difference between relational and non-relational databases? Well, you're not alone. In the realm of data management, these two types of databases play crucial roles. They're like the yin and yang of data storage, each with its unique strengths and weaknesses. Today, we aim to unravel this complex web, making a comprehensive comparison between these two database systems. So buckle up as we delve into the world of databases, deciphering the key differences between relational and non-relational systems. First up, let's get to grips with relational databases. At their core, relational databases are all about structured and organized data. They use tables to store information, with each table representing a specific entity like a customer or a product. These tables are linked to each other through relationships, hence the name relational database. Now, what makes these databases stand out is their use of a special language known as SQL, or Structured Query Language. SQL allows users to manage and manipulate data in a relational database, making it a key feature of this system, but it's not just about organization and language. Relational databases also offer key advantages such as data integrity, flexibility, and security. Data integrity ensures that the data in the database remains accurate and consistent. Flexibility allows for the data to be easily manipulated and accessed. And security, well, that's paramount in today's digital world, isn't it? However, it's not all roses. Relational databases do come with their set of disadvantages. They can be complex to set up and maintain. Scalability can be a challenge, especially when dealing with large volumes of data. And let's not forget cost. Depending on the size and nature of the operation, relational databases can be quite costly to implement and run. In essence, relational databases are robust systems, offering organized storage and high data integrity, albeit with some scalability and complexity challenges. Now, shift gears and uncover the world of non-relational databases. Non-relational databases, also known as NoSQL databases, offer a different approach to data management than their relational counterparts. These databases are designed to handle large volumes of data, offering flexibility, scalability, and speed that can be critical in today's data-driven world. One of the most notable features of non-relational databases is their flexible schema. This means that unlike relational databases, which require predefined schemas, non-relational databases allow for data to be stored in multiple ways. This flexibility can be a major advantage, particularly when dealing with diverse or rapidly changing data. Non-relational databases also offer a variety of data models. These include key-value stores, document databases, columnar databases, and graph databases. Each of these models has its own strengths and is suited to different types of data and applications. But like anything else in the tech world, non-relational databases are not a one-size-fits-all solution. They come with their own set of challenges. These include a lack of standardization, which can make them more complex to work with, and potential data integrity issues, as they do not enforce the same level of data consistency as relational databases. To sum up, non-relational databases are flexible and scalable solutions, perfect for handling large volumes of diverse data, though they come with their own set of challenges. Having unraveled both systems, it's time to put relational and non-relational databases head-to-head. Let's kick off with structure. Relational databases are like a well-organized filing cabinet. They store data in tables, with each piece of information neatly slotted into its own row and column. Non-relational databases, on the other hand, are more like a big box of assorted items. They can store data in a variety of formats, including key-value pairs, wide column stores, and document stores, giving them the flexibility to handle diverse data types. Now, onto scalability. Non-relational databases are the clear winners here. They're designed to scale out, spreading data across multiple servers to handle larger loads. Relational databases, while they can scale up by adding more powerful hardware, struggle with scaling out due to the complexity of their structure. Speaking of complexity, relational databases require a clearly defined schema before data can be inputted, and changing that schema can be a complex process. Non-relational databases are more flexible, allowing for schemaless data input and easy changes to the data structure. Next up is speed. Non-relational databases typically offer faster read and write times, especially for large volumes of data. However, relational databases can be faster when handling complex queries that involve multiple tables. Data integrity is another critical point of difference. Relational databases excel here, ensuring that data remains consistent, accurate, and reliable through the use of transactions and constraints. Non-relational databases, while they offer eventual consistency, can't guarantee the same level of data integrity. So, which type of database is right for you? If you're dealing with structured data, complex queries, and data integrity is paramount, a relational database might be your best bet. But if you need to handle large volumes of diverse data, and scalability and speed are your top priorities, a non-relational database could be the way to go. While both types of databases have their pros and cons, the choice between relational and non-relational systems largely depends on your specific needs and the nature of the data at hand. So, we've journeyed through the realms of relational and non-relational databases. We've seen the structured elegance of relational systems, their tabular clarity, and the flexibility they offer in managing diverse data. On the other side, we've explored the world of non-relational databases, witnessed their scalability, and how they thrive in handling vast volumes of unstructured data. Remember, in the world of databases, there's no one-size-fits-all solution. It's all about finding the right fit for your data needs.